So Xu and Tenenbaum did another study in 2007, which showed that children are sensitive to how the data are selected for them in a way that a Bayesian learner is as well. And so the way that it worked was this. If the child believes that the data are randomly sampled from all the available data out there, right, that is, it's a truly random sample, then it's a very strong suspicious coincidence if we only see subordinate level items. So if we randomly pick out a bunch of dogs and they all happen to be Dalmatians and we say, oh, FEP, well, then that's when a Bayesian learner and children are going to favor that subordinate level hypothesis that FEP means something more specific, the species of dog, right? You're going to prefer a Dalmatian and you're not going to generalize FEP to mean all kinds of dogs, right? And this is what we see in this graph right here, which comes from their paper. And again, both the child and the model are very happy to do this. However, if the child instead believes that the data are selected for some other reason, maybe because they're similar to each other or there's some other sort of reason that this is not a random sample, I'm actively trying to find things that are very close to each other and they all happen to be FEPs, right? If they are not picked at random, then both children and a Bayesian model no longer have that preference to think FEP means the most specific hypothesis. Instead, they sort of default back to the basic level hypothesis. So actually, I should say the y-axis here is how much you favor the subordinate hypothesis in these circumstances. And they favor, they have the basic level hypothesis that they fall back to when they're not picked at random, when these data points are not a truly random sample, which again is just showing you that children are like Bayesian learners. And so in the sense that Bayesian inference seems to be a good way to capture the kind of inference that's going on in children.